Here we're going to talk about two other small-scale wind systems, mountain and valley breezes. In order to understand these, we're going to use the same process we did with land and sea breezes. Let's start with a valley breeze. A valley breeze occurs during the day. Let's look at the figure to the right. Just like before, we have our surface labeled and our area aloft labeled. Our two surfaces are a mountain and a valley in this case. Now we begin with the causal continuum. First step, radiation. For this scenario, we actually do have a radiation difference. If you look at the yellow arrow, it's representing incoming solar radiation from the sun. Notice how it's hitting the slope of that mountain at a 90-degree angle. With the mountain collecting this very directly, it's actually going to receive more radiation. Think back to the flashlight example. If you hold the flashlight straight up, it's going to illuminate a very small area brightly. But if you hold it at an angle, it's going to illuminate a larger area not as bright. What's happening with the mountain would be the equivalent of holding the flashlight directly overhead, because again, that energy is coming in at a 90-degree angle. At the valley, it's going to be coming in at some angle less than 90. Due to this, the valley is going to receive less. Because we have radiation differences, we're now going to have temperature differences. Even though most people think of temperature dropping with height on a mountain, in this scenario, as long as the mountain isn't too tall, the slope that's facing the sun can actually have higher temperatures than the surface or valley, and that's because of that direct radiation. So that's what we're going to label here. The mountain is warmer than the valley. Because of these temperature differences, we're again going to have density differences, drawn as such with these molecules. Above the mountain, these higher temperatures lead to less dense air. Over the valley, where it's a little bit cooler, we notice those molecules are a little bit more compressed or more dense. These density differences are going to lead to pressure differences. Above each location, there are 7 molecules, so it appears that there are no pressure differences. But like we did with land and sea breezes, we can focus on this area aloft. Because above the mountain the molecules are more spread out, by the time we reach this height above the surface, there's still 1 molecule left. Whereas above the valley, because that column is more dense, there is nothing left. So we end up with a high pressure above the mountain and a low pressure above the valley. With pressure differences come wind, and wind is going to blow from high to low. Since winds are moving air molecules, we're going to be stealing weight from the mountain column and adding it to the valley. So at the surface of the valley, you're going to have higher pressure. Because you've stolen this weight from the mountain column, you're going to have lower pressure or lower weight on that slope of the mountain. Once again, with these pressure differences is going to come some wind, and it's going to blow from the valley to the mountain. Because these surface winds are coming from the valley, we name these valley breezes. Next up, we have a mountain breeze. Mountain breezes occur at night. Since we're at night, we're not going to have any radiation differences. However, there's still going to be some temperature differences. Because the slope of the mountain isn't receiving all that direct radiation, it's going to behave more along the lines of what we expect. As you get further and further away from the surface heating source, temperatures are going to drop. And so now the air above the mountain is colder, and the air above the valley is relatively warmer. With these temperature differences, again, come density differences. Where it's colder above the mountain, we have more compression and more dense air. And over the valley, where it's warmer, the air is a little bit more spread out, a little bit less dense. With these density differences, again, come pressure differences. Above each location, it may appear that there's 7 molecules, but if we again focus on this area aloft, there's still 1 molecule of air left above the valley because of that more spread out nature of the column. Whereas above the mountain, because it's more compressed, there isn't anything left above this height aloft. And so we now have a pressure difference. High where you still have weight above you on the valley, and low above the mountain where there's no weight above you. And so air is going to move from high to low. And that's our wind. Now, since we're stealing weight from the valley and adding it to the mountain, we create a high pressure system at the surface of the mountain. Because we've stolen this weight from the valley column, you're going to end up with a lower pressure or lower weight at the surface of the valley. Now, winds are going to blow from the mountain to the valley, from this area of high pressure to low pressure. And this is why we call it a mountain breeze, because winds blow from the mountain to the valley at the surface.